So exponentials and logarithms, and we have some basics like index form to logarithmic form and logarithmic to index form. Exponential function, just sketching of graphs. When we have graph y is equals to 3 raised to power x, so we know when the value of x is 0, this is 1, and when it is 1, 3, when it is 2, that is 9, so it keeps on increasing. At x0, that gives us 1. On right hand side it keeps on increasing. On left hand side that keeps on decreasing but never touches the x-axis. The value never becomes 0. So these are simple sketches and about the questions. Okay, so when we say log of n to base a, we know that n is greater than 0, a is greater than 0, and a cannot be equal to 1. Why so? Because log of 1 is actually equal to 0, and if we have a in the base, if we apply change of base law, we can write log n divided by log a, and log 1 is 0, that is why the base cannot be 1. So if we write 0 in the denominator, that would be undefined. It says write each statement as logarithms. If I have to change this into logarithmic form, let me write as variables x raised to power y is equals to p. Now this will be y is equals to log of p to base x. One way is we know that power will come down and this will go on the other side. Other way is we can just write apply logs on both sides, like x raised to power y is equals to y, applying log on both sides, log and log. This y comes down using power law, so that is why log of x is equals to log of p. Now I'm dividing log x on the other side, so log of p divided by log of x, and we can now write them as single log, which is log of p to base x. And when we have like same values, for example, I write log of 27 to base 3. I can write log of 3 cube to base 3. Now this 3 is coming out using power law. So this is 3 log of 3 to base 3. Now 3 log to base 3, basically if we write log of y to base y is equal to 1. Why so? Because this is log y divided by log y. So this bracket right here becomes 1 and the answer is 3. If we have a number log of 16 to base 2, I can write log of 2 raised to power 4 and 2, and now 4 is coming out using power law, that is log of 2 to base 2, and answer is 4. If we have such number in base like log of 2 base 16, so that will be log of 2 base is 2 raised to power 4. Now this 4 comes out but as reciprocal. This 4 comes out but as reciprocal. So 1 by 4 log of 2 to base 2, which is 1 by 4 at the end. And then we have product law. If like we are adding the numbers log x plus log y plus log z, when we write them as single log, they are multiplied x into y into z, and with the sign of subtraction that goes in division. Log of x minus log of y plus log of z. The positive ones goes with multiplication. This would be x z divided by y. The one with negative sign goes down. So if I have like a question log of x plus 3 log y, to write them as single log, this will be log x plus log y cube first, reversal of power law. Now we are going to write them as single log, that is log xy cube. So with numbers, and it says use your calculator to find the following. You just need to know how to use your machine. Some calculators have a button which appears like this, and you can fill in 40 and 3. Others don't have this. If you have a simple one, you can apply punch log 40 divided by log of 3. Rewrite using a logarithm, so that is 4 is equals to log 256 to base 4. This is minus 2 is equals to log of 1 by 9 to base 3. This is 6 is equals to log of, these are 1 2 3 4 5 6 to base 10. This is reverse of that, logarithmic to index form. So I'm taking this 2 on the other side and becomes 16 is equal to 2 raised to power 4. For this, 5 goes on the other side, 25 is equal to 5 raised to power 2. 9 goes on the other side, 3 is equals to 9 raised to power 1 by 2. Question number 3, without using a calculator. So I know 8 could be written as 2 cube. So this is log of 2 cube to base 2. This 3 comes out. 3 log of 2 to base 2. So answer is 3. For this it could be written as 5 square. So I'm writing 2 log 5 to base 5. So final answer is 2. If you look at this number, that is log of 0.25 could be written as 1 by 4 to base 4. And I'm taking that 4 in the numerator and writing it as log of 4 minus 1 to base 4, bringing this minus 1 outside, minus 1 log of 4 to base 4. So final answer is minus 1 for this expression. Question number 4 says without using a calculator find the value of x. So changing it into index form, 4a, 5 goes on the other side. This is x is equals to 5 raised to power 4. 5 times 25 into 5 is 125. Into 5 is 625. Look at this D part. 2 goes on the other side. X minus 1 is equals to 2 cube. So that would be x minus 1 is equals to 8. 1 goes on the other side. So x is equals to 9. E part, 3 goes on the other side and makes it 4x plus 1 is equals to 3 raised to power 4. 3 times 9, 3 times 27, 3 times is 81. So 4x plus 1 is equals to 81. 4x is equals to 80. 80 divided by 4x is equals to 20. Use your calculators. So again, you just need to know how to use that machine. Without using calculator, justify why the value of log 50 to base 2 must be between 5 and 6. Okay, so if I have this log 50 to base 2, I know that it is close to 49. So I'm writing it as log 49 approximately equal to 49 is 7 squared. So log of 7 square base 2, base 2. So I have to convert it into something which is close to power of 2. So 2, 4, 8, 16, 32 and 64. If I look for 50, which is between 32 and 64, so I'm writing 64, which is more close to that, to base 2. That would be 1, 2, 3, 4, 5, 6. So log of 2 raised to power 6 to base 2. This 6 comes out, answer is 6. And I know that I have over exaggerated. So it must be less than 6. One part. Second, if I write like log of 32, which is 2 raised to power 5. And I know now we have downsized it. So basically log of 32 gives to base 2 gives me an answer of 5, and log of 64 to base 2 gives an answer of 6. So when we are talking about log 32 to base 2, and log 64 to base 2. So log 50 to base 2 must be in between 5 and 6. Calculator, skipping it. Find the values of log 2 to base 2 is 1. This is again 1. This is again 1. Explain why log a to base a has the same value for all positive values when it is not equal to 0. It cannot be equal to 0 because when denominator is 0, it is undefined. So log a to base a, why does it have the same value? Because it could be written as log of a divided by log of a, known as change of base law. When we do not write anything, it is understood that base is 10. Find the value of these. Now this is log 1 in numerator, log 2 in base. Log 1 is 0, so 0 divided by anything is 0. Again 0, again 0. Laws of log. Converting it into index form and back. Take two logarithms with the same base, a and a, okay. So when we convert them, x is equal to a raised to power m, y is equal to a raised to power n, and when I'm going to multiply these two, x and y, I can also multiply the right hand side. So xy is equals to a raised to power m plus 1. Simple rules of indices. So log of xy, and xy alone could be written as a raised to power m plus n, and we've already discussed when we multiply we just add them, and when they are dividing we just subtract them. So multiplicative law, when we are adding we multiply them, when we are subtracting we divide them, and this is power law. Okay, write a single law. Now this is plus, so 6 7 times is 42, so we write log of 42 to base 3, and when we are subtracting 15 divided by 3 is 5, so we write log of 5 to base 2. Now when we deal with this is taking this power back, that becomes log of 3 square to base 5 plus log of 2 cube to base 5. This 3 goes on 2, and this is log of 3 square is 9 to base 5, log of 8 to base 5. Now this is positive sign, so we will multiply. 9 8 times is 72, so log of 72 to base 5 expressed as single log. Write in terms of log x to base a, y to base a, or z to base a. So let's try this first one. This is log of x square y z cube to base a. Now I'm going to split them. They are being multiplied, so I will use a positive sign. So log of x square to base a plus log of y to base a plus log of z cube to base a. I'm getting rid of these powers, bringing them to left hand side using power law. 2 and 3 gonna come out. So 2 log of x to base a plus log of y to base a plus 3 log of z to base a. So they are written as log of x, log of y, or log of z to base a. Solve the equation. The only unknown is x. Log of 4 to base 10 plus 2 log of x to base 10 is equal to 2. That's the question. I'm going to express it into single log. Taking the power on this, that is log 4 base 10 plus log x square base 10 is equal to 2. Now this is a positive sign. When we combine them we multiply. So log of 4x square to base 10 is equal to 2, expressed as single log. Now convert it into index form. So 4x square is equals to 10 raised to power 2, and x square is equals to 100 by 4 is 25, square root both sides, x is equals to plus minus 5. Now once done, we know that x lies here and it cannot be negative number. So final answer is x is equals to 5 only. Okay, let's try something from the exercise. this exam style question. Let me copy this. The question says log of x plus 1 to base 3 is equals to 1 plus 2 log of x minus 1 to base 3, and it says show that we have to show 3x square minus 7x plus 2 is equals to 0, and sometime it says convert it into quadratic form. Okay, so log of x plus 1 base 3, on the other side I'm going to take this 2 here, which will be log of x minus 1 whole square to base 3. And what about this one? I have to change it and I have to see log 3. So log 3 to base 3, because the base was 3 and this is equal to 1. Now we can convert it into single log. This is log x plus 1 base 3. On the other side, that is a positive sign, so we multiply. This becomes log of 3 into x minus 1 whole square to base 3. Now students sometimes say cancelling log. That is not cancelling log, we say applying anti-log, and you can get rid of this and just equate x plus 1 with 3 into x minus 1 whole square. Now we are simplifying. That is 3a square minus 2ab plus b square, 3x square minus 6x plus 3, and on the other side x plus 1. 3x square minus 6x, bringing that x here is minus x, plus 3 minus 1 is equals to 0. 3x square minus 7x plus 2 is equals to 0, and 3x square minus 7x plus 2 shown. Any confusion till now? Now these are those questions which definitely does not give exact answers. So 3 raised to power x equals 20, just applying log on both sides. So it just becomes x is equals to log of 20 divided by 3, and then there is use of calculator. Now 5 raised to power 2x minus this, you can use substitution as well or solve it as it is, considering that this is the squared part, this is the single part, like x square or y square. So I would like to replace it with y, and let me say 5 raised to power x is equals to y. So I can write this equation as y square minus 12y plus 20 is equals to 0. Now let's look for the factors of 20, which is 10 and 2. So y square minus 10y minus 2y plus 20 is equals to 0. Y common, y minus 10 minus 2 common, y minus 10, and I get y minus 2 as first vector, y minus 10 as the other factor. Final answer is y is equals to 2 and y is equals to 10. Now I can replace it back. So 5 raised to power x is equals to 2, x is equals to log of 2 to base 5 one value, and other with 10. 5 raised to power x is equals to 10, so x is equals to log of 10 to base 5. So log of 10 to base 5 or log of 2 to base 5, you can do it with either method and then use calculator. Exercise. Okay, question number 3. Solve the following equations using your answers to giving your answer to 3 significant figures. Find where appropriate. Okay, using this. Now I'm using log. This is x plus 1 is equals to log of 2000 to base 3. Then this 1 goes on other side, leaves me with an answer of x is equals to log of 2000 to base 3 minus 1, and then use of calculator. This right here is x minus 3 is equal to 5 raised to power minus 1, which would be 1 over 5. And next step is x is equals to 1 by 5 plus 3. and we'll definitely simplify it. Sketch 4 raised to power x. When x is 0, it intersects at 1. So this is the sketch. Solve the equation this. So again, I need some writing space. So this is 4 raised to power 2x minus 10 into 4 raised to power x plus 16 is equals to 0. Let's say y is equals to 4 raised to power x. So this is y square minus 10 y plus 16. So I'm looking for factors of 16. Y square minus 8y minus 2y plus 16 is equals to 0. Y common, y minus 8 minus 2 common, y minus 8 is equals to 0. Y minus 2 times y minus 8 is equals to 0, and 1 is y equal to, other is y equal to 8. Now we can replace that back. So 4 raised to power x is equals to 2. On the other side, 4 raised to power x is equals to 8. I can solve this without calculator, which is 2 raised to power 2x is equal to 2 raised to power 1. Therefore 2x is equals to 1 and x is equals to 1 by 2. On the other side, this is 2 raised to power 2x is equal to 2 raised to power 3. So therefore we substitute the powers, the bases are same, so x is equals to 3 by 2, either 1 by 2 or 3 by 2. Change of base law when needed. So we can do that. For example, I have like log of b to base a. I can write them as log of b and log of a and change this base, but this has to be same. And when we take the reciprocal, they also switch like this. It was b to base a, it became a to base b. We actually don't need them because we will be having calculator at all times, unless until examiner says that show that this is the form. Okay, now we see that we have one of the x in the base and one x in front of log. So log x, you just take the reciprocal and that changes. Now why are we substituting this with y? To make an equation, and then we can substitute it back again. That's easier to handle. Let's try some questions. Okay, this question right here, 3a. This is log of x to base 2 is equal to 8 plus 9. I'm taking that reciprocal, so this becomes log of x to base 2. Again, log of x to base 2, let it be equal to y. So I can write y is equals to 8 plus 9 over y. I'm multiplying the whole equation with y to get y square is equals to 8y plus 9. Rearrange y square minus 8y minus 9 is equals to 0. Factors y minus 9y plus y minus 9 is equals to 0. Y minus 9 plus 1, y minus 9. So it gets y plus 1 equal to 0, y is equals to minus 1. And on the other side, y minus 9 equal to 0, y is equals to 9. Now we have this, that log of x to base 2. So log of x to base 2 once minus 1. So x is equals to 2 raised to power minus 1, which is x is equals to 1 by 2. And for 9, log of x to base 2 is equals to 9. X is equals to 2 raised to the power 9. Chapter review. Which question do you suggest we try? Question 11, okay. Find the positive value of x such that log of 64 to base x is equals to 2. Solve for x. Okay, first of all the bases are same. Find the positive value of x such that, so this is 64 is equals to x raised to power 2, and I can write that 8 square is equals to x raised to power 2. So therefore x is equals to 8, first part. And for second part, we already have base as 2, so log of 11 minus 6x to base 2, and on the other side I'm applying power law, log of x minus 1 whole square to base 2, and for this 3 I'm writing log of 2 to base 2. Log of 2 to base 2 is actually 1. Now this 3 can go there, and I can write log of 2 cube to base 2. Now you see all of these are converted into 2 base 2, so we can write them as single log 2 base 2, and on the right hand side they are added, so we'll multiply 2 cube is 8x minus 1 whole square to base 2. Now we apply anti-log, 11 minus 6x is equals to 8 into x minus 1 whole square, and we can simplify. 11 minus 6x is equals to, on the other side, that is a square minus 2ab plus b square. 11 minus 6x is equals to 8x square minus 16x plus 8x square. This 6 comes on other side, we are left with negative x, and 8 minus 11 minus 3 is equals to 0. Now we are looking at 8 3 times is 24 and 6 4 times is 24. So 8x square minus, but 6 and 4 will not adjust. So factors could be, what could be the factors? 12 and 2, minus 12x plus 2x minus 3 is equals to 0. Taking out common, 4x, I'm left with 4x minus 3, 2x minus 3, and plus 1, 2x minus 3 again. 4x plus 1 equal to 0, 2x minus 3 equal to 0, x is equals to 3 by 2, and x is equals to negative 1 by 4. Now be careful. Once we have this equation, we always have to recheck. I'm sure about the positive value, but when this is negative 1 by 4, see right here. If I just substitute it, and we already studied in the start that log of n to base a, both of these values cannot be negative. So this is rejected, and final answer is x is equals to 3 by 2. Any confusion?